Here's a teaser. Take a look at this oddly constructed class called T, where I've imported two things from two different modules. I've performed an assignment referencing something outside of this class, and I've defined a standard instance method. And the question is, which of these methods can I actually call, and I'll get some answer that's not an exception? Well, presumably, I can call object.bar. That should work. This is fairly straightforward. Can I call object.foo? Surprisingly enough, that works. Turns out you can construct objects by assigning methods referring to functions that exist outside of that class, and as long as that thing looks like an instance method, has a self parameter, everything just works. The question is, when I try dumps and repeat pulled from the itertools module, dumps does not work, but repeat does. Why on earth does one of these fail and the other one succeed? And how on earth does this even work in the first place? It turns out the answer is the descriptor protocol. Here's the trick to this entire puzzle. Absent any of the scoping tricks with saying foo equals foo or introducing something into scope by importing it, the core of this trick is all functions written in pure Python are automatically given the descriptor protocol. In other words, foo, by virtue of having been written in pure Python, is made a descriptor by being given this get method. And so when we try to access this method from this object, we say object.foo. We go down the get attribute protocol. As part of that get attribute protocol, we invoke the descriptor protocol because the thing that we see happens to exist on the type, and it happens to look a certain way. It happens to have this get method, and we invoke this get method. The same is obviously going to be the case for bar, object.bar. And if we take a look at the two modules that I chose to pull functions in from, one of these modules was written in pure Python, and the other module was not. In the case of the JSON module, well, that was written in pure Python. And thus, all of the functions that are defined in this JSON module are going to implement the descriptor protocol. If I look at dump s from the JSON module or load s or anything else, they're written in pure Python, and so they implement the descriptor protocol. But if I look at the itertools module, which is largely implemented in C, and I take a look at the contents of that module, these functions are not written in pure Python. They do not implement this get method. They do not implement this descriptor protocol. And thus, when I call object.repeat, because I do not invoke the descriptor protocol, this is just called like any other regular function, and it doesn't try to add in a self parameter, which is what the descriptor protocol happens to do for instance methods, and it just works. Whereas if I call object.dumps, it's going to say, oh, hold on a second, this is a Python function, so you intended this to be an instance method, and it has this get method, so I'm going to invoke this descriptor protocol, and as part of that descriptor protocol, I'm going to insert that self parameter, and your dumps call will say, I'm not going to work because you've given me too many arguments. It takes one positional argument, but two were given. That second positional argument is that self that is transparently being added as part of the descriptor protocol on all Python functions. In Python 2, we used to have this distinction between bound methods and unbound methods, and Python 3 eliminated that distinction. Instead, in Python 3, all pure Python functions have the descriptor protocol invoked, and as part of that descriptor protocol, they insert that self attribute for you. Why don't we try implementing our own version of instance method, class method, static method, and property to see how this all works? So let's take a look at how class method, static method, instance methods, and property all work. Here, you can see I've implemented a very simple class, and in that class, I've implemented a standard instance method using just a regular pure Python function, which, as we know, automatically implements the descriptor protocol. Well, instead of making use of that functionality, I'm going to create a decorator called instance method, and I'm going to show you what that descriptor protocol actually does. And for shorthand, my instance method will just be a data class that has a single entity that just takes the function that it's wrapping. Well, as I said, In the descriptor protocol, you really are just implementing this get method so that in that get attribute protocol, when this thing is looked up via that dotted lookup, and you find it, you call a special method, pass in some special arguments, and get a special result. And so in the case of all four of these, we're going to implement this get method, and we're going to pass it the same arguments, self, instance, and owner. Where the instance is the particular instance of this class that you're operating on, and the owner happens to be the type of that object, happens to be the class where this thing was found. Here, our implementation is quite simplistic. Instead of returning the function directly, which would be the case of, say, static method, what we're going to do is we're just going to bind this function. What we'll do is we'll return a wrapper. And this wrapper can be as simple as just a lambda that forwards all the positional arguments and all the keyword arguments and just inserts one special argument, our self. Here you go. This is what an instance method really is. It's just a Python function written in pure Python, which happens to have a get method automatically added to it, where that get method just happens to return some bound version of this function where you pass through all the position arguments, you pass through all the keyword arguments, and you also happen to insert that self argument. And to complete this exercise, we might even do something like this, just so that our help text and our naming of this function looks good. There we go. For our next exercise, let's see if we can implement class method. And in the case of class method, we'll try the same thing. We'll implement a get method. And here you can think, well, in our get method, we're not doing that much that's different. Instead of returning the function directly, we're going to return that function bound. And so we'll start by returning just a pass-through. This will return a function which just passes through all of the positional arguments and all the keyword arguments. And we'll insert the owner. And just to wrap this up, we'll use wraps, and there you go. That's class method. And next, let's take a look at static method. And in the case of static method, what we'll do is we'll write our descriptor protocol get method, and instead of returning self.f, oh, hold on a second, we'll just return self.f. That's all you have to do for static method. You can see static method is the simplest of all of these. And surprisingly, you can see in all of these cases, the same underlying mechanism is used to implement all of these different behaviors. The last portion of this is we'll take a look at property. And property behaves slightly differently than class method and instance method. What we get when we implement a property is we get to hook some functionality behind something that just looks like an attribute lookup. But one thing that we're going to have to do before we implement property is we are going to have to change our calling syntax here. We're just going to say object.foo instead of object.fooCalled. So it's one small detail that we're going to have to change just to make sure that our property is invoked correctly. And so in our get implementation of this descriptor protocol, what we'll do, instead of returning the underlying function or returning a bound method of that underlying function is, we'll just invoke the function and we'll pass it a single argument, and there we go. And so what you can think is sometimes you want to have things which are both class methods and properties, or static methods and properties, or some combination there. And you may find that compositionally that doesn't always work. There is an ordering requirement when you want to try to combine these. And so if you want to look beyond these four examples of the use of the descriptor protocol, instance method, class method, static method, and property, you can think of very interesting things that you could create yourself. You may have run across cases where that property, well, you know what, that property doesn't take any extra arguments, and maybe you want to be able to supply some additional arguments that aren't on the instance type. You could create your own version of property that finds a way to supply those. Sometimes you might want to do things like mix and match these. You might want something that's both a property and a class method. You may even find an ordering dependency where you can do class method and property in one order but not in the other order. One way around that might be you write your own implementation of the descriptor protocol that fuses the property behavior and the class method behavior. You can see in this case it's as simple as passing in the owner instead of the instance. And so when you look at this underlying mechanism, and you see how simplistic this mechanism is, and how it really is just following a sequence of steps, and how a consequence of this mechanism is a wide range of different functionalities, you can see that There are cases where you might want to dismantle this mechanism and implement your own complex versions of what you want the descriptor protocol to be able to do for your type.